Function f of x has derivative f dash x, and then we're given a graph of y equals f dash x, and asked which point corresponds to a local minimum of f of x. So what we need for a local minimum of f of x is that f dash x is going to equal 0. Okay, that is one condition that is necessary but not sufficient actually. We need more than that. But what it does mean is I can rule out e, d, and b because they're not 0 there. I also require that the second derivative is greater than 0. This is a normal test. You find the stationary points, and then to check whether the stationary points, you find the second derivative. If it's less than 0, it's a maximum. If it's greater than 0, it's a minimum. If it's equal to 0, then you need to do a different test. So and let's just look at think about f dash x. F dash x is the gradient of, sorry, f double dash x is the gradient of f dash x. So I'm looking for a positive gradient on my graph where, remember, f dash x is 0. So for A, it's negative. Actually, that would be a local maximum. For C, it is positive. That's going to be my answer. And then for F, actually, it's negative and then positive. The second derivative is changing sign. This would be a special case where it's a point of inflection, stationary point. You don't normally know that when you just get 0, by the way, but because I can see it from the graph that it's changing sign, I can say it for sure. Points of inflection are something that are covered in more detail in year 2, and I don't think they're not on the TMUA, so you don't need to kind of know this as such, but it's still worth talking about, especially because if we talk about B and E, okay, they are not stationary points, but actually the gradient is changing at those 2 points. Both of these are non-stationary points of inflection. They'll just look slightly different. Let me just say, so something like this. See, this doesn't have any stationary points, but here the gradient is decreasing for this period. And then there comes a point when the gradient starts increasing. And that is the second derivative, the gradient of the gradient, like changing sign, because it goes from the gradient decreasing to increasing. That would be a point of inflection. There's other types of points of inflection too. I mean, we've looked at the stationary ones, but you could get like this kind of thing going on, where the gradient is increasing and then decreasing. That, lots of different situations. But for our purposes, we just have to identify, I'd say, like this key information and work out that it's C. I just wanted to talk about what some of the other points refer to as well.